Hello everyone, my name is Reese Lindmark and you are listening to The Reese Show. On the show, we're trying to clarify what a good future looks like. I know we're all a bit sad about late-stage capitalism, and we want to transition to something, but we don't really know what's next. So, on the show, we interview experts about what is emerging, this beautiful future vision that we can all lean into. I hope it gives you a sense of purpose and clarity about the future. If you like the show, feel free to do something about it. You can leave us a 5-star review, you can tell your friends, you can name your first child Reese, whatever makes you happy. And if you really dig it, we have an online school called Root, where we help folks understand these root level systems to find our route forward. We have cohorts of world-class systems thinkers that run every couple of months. So if you're interested in that, check us out at root.co. That's ROOTE.co. Thanks. Today's episode is with David Christian, and David is one of the founders of Big History, and we have a great conversation about any and all things in big history. We really dive into information and energy and the ethnosphere and the new sphere and cosmic evolution, and it's really quite juicy. So I hope you enjoy it. And as a note, sorry that my mic is bad. There were some issues with the recording, but it's him talking, which is good, so you don't have to listen to me too much. Okay, thanks. And hello, listeners. Today I'm excited to chat with David Christian. David is a historian who has helped found the field of big history. He has written multiple books on the subject, including my favorite, Origin Story. And with Bill Gates, he is the co-founder of the Big History Project, which has built free online high school courses in big history. David, thanks for being on the show and welcome.
Pleasure.
Yeah, it's exciting. And I think that, David and I, for me, I'm currently writing a book that has some big history topics. And so chatting with the founder of Big History is an amazing opportunity. And I think to start, I would just love to know, David, your background. Like, how did you transition from Russian history into big history and kind of looking at the bigger picture? What drew you to big history?
Yeah, good question. And I'm not always sure what the correct answer is myself, but I think it goes something like this. As a teenager growing up in England, I got fascinated by Russian history and things Russian. I sort of fell in love with things Russian. But this was also the time of the Cold War. So I was aware of Russia as a country that could blow me up. And I remember the Cuban Missile Crisis. I remember very vividly being at school and wondering with my friends if we'd see each other next day. And I also remember thinking very vividly, my God, are there people over there who are thinking the same thing? And how crazy this is that we humans are now so damn clever that we can blow ourselves up. And I think those sort of thoughts really, over the years, pushed me towards big history. I taught Russian history because I fell in love with Russia, but I also, during the Cold War, it was the other side. Russia was the other side. And I felt that, we needed to know as much as we could about the other side of the Cold War. And I taught Russian history for many years, and it felt significant and important. But more and more, I became drawn by the thought that in a world in which we can blow each other up, we are interdependent in a way that has never been true before. So increasingly, we humans are really part of one interdependent global community. And if that's true, then it followed that we ought to be studying the history not of particular nations. There's no reason why we should not carry on doing that, but we also needed to study the history of humanity, of our species. And I realized that no one really does that. We don't teach that history in our schools. We rarely teach it in our universities. And I had not heard of world history. So I began, this was sometime in the mid-'80s, to wonder how you would teach a course on the history of humanity. And very quickly I decided the first thing you have to do is you have to take the Paleolithic seriously, which increasingly I want to call the foundational era of human history, 200,000 years or more, during which humans lived in small hunter-gatherer groups. But then I realized that to do that seriously, you have to talk about human evolution, how humans evolved. So I thought, my God, now I'm talking about biology. And then to talk about evolution seriously, you have to go back and back and back to the evolution of life on Earth. Um, so now I'm going back 4 billion years, and I have to talk about planet Earth, which means talking about geology. So these questions about the history of humanity pushed me back and back and back until I found myself wondering, what is the history of the universe of which we are a part? And modern Big Bang cosmology actually gives us a framework for that story, because the Big Bang happened about 13.8 billion years ago. So I began to wonder if it was possible to teach a course that would help us understand our place in the history of the universe as human beings, by telling the story of the whole universe. And at first it sounded completely crazy, but now, some 30 years later, it sounds like the most obvious thing to be doing. Unfortunately, still, it does not seem obvious to most educators, most universities, and most designers of school syllabi. But the more we get involved in issues like global warming, the threat of nuclear war has not gone away, of course, the more I think it's absolutely crucial that people learn this story and they understand how we humans fit into the history of the universe, and they understand that we live at a critical turning point in the history of planet Earth. Reese, that's probably a bit long, but I hope that gives some idea of how I got from Russian history to the idea of teaching the history of the whole universe.
No, I love it. I think there's a bit of, yeah, I mean, for me, I'm thinking about that, that curiosity that you had is similar to my own, where, you and I didn't decide, oh, you must, tell the whole history of the universe. Instead, you said, hey, I'm going to start with, humanity. And then you have to keep on going backwards. Oh, origins of life. Oh, origins of the universe.
Yeah,
So you're just kind of following your curiosity there. And I
but
also think, or,
it's not just curiosity, of course. There's a very clear intellectual logic to it. I mean, to understand, I mean, this is the logic of all history. Historians will tell you that you can't understand today's society unless you understand what it emerged from. Now, that
yeah.
simple way of thinking, why should we stop 5,000 years ago? I gather that the AP World History syllabus in the US now begins in the year 1200. Um,
Wow.
why, to understand everything that's happened since 1200, you need to understand the earlier history and back and back and back. So that the logic is very, very simple. And I more and more wonder why we stop that logic at a certain point. I know some of the reasons. Historians will say, "Oh, look, I can't talk about evolution because I'm not an expert. I'm
Mm-hmm.
not a biologist." Well, if talking about evolution is crucial to understanding our nature as a species, what we are, what makes us different, then, goddamn, I think you ought to start looking at evolution, and ditto for geology and astronomy. So that's the logic. It's a very simple logic.
Totally. And do you think, I mean, just for our listeners to give them a bit of, some of the big learnings, and I know that there's, just for our listeners, there's a great 20-minute TED Talk that David gives, and some other, obviously, a great book, Origin Story. But could you give us the, like 1 minute version of like, how things have evolved since the beginning of time?
Oh, my, a 1 minute version.
Your time begins now. Yeah.
Yeah, well, let me stand back a moment before having a go at that, and saying that when I began teaching this, I had no idea how to put the story together, because it's not a story that we we generally try to put together. So, I knew I could read cosmologists, I could read geologists, I could read biologists, but and each of them tells their own story. Um, how do you put all those stories together? That for me was the big problem. And when I began, it really, for several years, I actually wondered if there was a story there, or perhaps, in fact, the stories were so different you couldn't put them together. But within a few years, I realized there was a story. All of these different stories could be seen as part of one single story. And certainly the version I tell is a story of increasing complexity. So here's my shot at the 1 minute version. um, the Big Bang, 13.8 billion years ago, created a very, very simple universe. It consisted of hydrogen and helium and lots of energy. It was very, very hot, and it was expanding fast. That's there were no planets, there were no stars, there was certainly no living organisms. And then as you watch the evolution of that universe over 13.8 billion years, what you see is that different parts of it take on different qualities. And in some very special regions, I call them Goldilocks regions, um, existing elements combined in new ways to create more complex things. So the big history story, as I understand it, can be told as a series of threshold crossings, points where the universe suddenly generates something new. So stars are one of the first of these new things. And then stars generate new chemical elements. With new chemical elements, you can create new types of matter. So you can create planets, for example, which are chemically much more complex than stars. And once you have planets, you have very special environments that are chemically very complex, so complex that you can create the first living organisms. At least we know that happened on our planet, and there's a good bet it happened elsewhere. So once you've got living organisms, you've got organisms that are already fantastically complex and that evolve to become more and more complex. So then you can tell the story of how more greater diversity of organisms appeared until eventually you have human beings. And you can ask, what is different about human beings? And in the version I tell, at least, what is different is that we human beings can share information in a way that no other organism can. So basically, none of us is on our own. We have in our heads huge amounts of information that was put into our heads by other humans and was thought up by other humans. And that's why we're so powerful. And that's why today we humans are transforming an entire planet. We're effectively managing an entire planet. And that's why I think of this moment in planetary history, certainly, as a turning point.
Yeah.
And then, so I've already cheated. I've taken more than a minute.
You're good. You're good.
The final payoff is that once you've told that story, then you have a hell of a lot of interesting questions about where it's going next. Where is it going to go in the next 100 years? Are we humans? Have we got to the point where we're so smart that we're going to blow ourselves up and destroy ourselves? So that'll be the end of that story. Or will we prove to be clever enough to avoid catastrophe and, in fact, keep flourishing and evolving for millions of more years on planet Earth? We don't know the answer, but the story provides a fabulous kind of launch pad for asking a story like that.
Yeah, I love it. I think, and I super agree with as you're going deeper on, you're like, is there a story that actually, like, across biology and chemistry and physics, all these things, is there actually anything that brings them all together? And as you say, this, the story of complexity that, and I like what you said, just reflecting it, the Goldilocks conditions with these threshold times where you have a bunch of things that exist that then combine into a new thing. So when it's stars, it's like you have the creation of or you have a bunch of hydrogen atoms, which then all combine with the free energy of gravity, boom, and then you get these new elements, and then those new elements can form the molecules, aka we're into chemistry now, which then those chemical molecules can then form with the electrostatic force into these replicating autocatalytic cycles and to turn into life, aka biology. And then once we have biology, that eventually base through photosynthesis and through respiration, through these awesome things, we get to the place where we are now, where we have humans. And now, as you say, we're in this special moment where, if we had cosmic evolution beforehand and then biological and kind of genetic based evolution, we're now in the world of cultural evolution, and how that it leads to our future is a big outstanding question. One thing I want to kind of dive deeper on here is, how do you think about energy versus information? And that you have a great quote in your book from Seth Lloyd that says, to do anything requires energy, and to specify what is done requires information. I think that, how do you think about how energy relates to information and how they turn into these threshold complexities?
Yeah, look, one of the things I love about big history is that it takes you into very deep territory, and sometimes you end up in territory where there really is no consensus. And I think that's true about both energy and information. They're very powerful concepts, but ask for a kind of rigorous definition of them. And even the best scientists and philosophers of science struggle. So these are kind of working concepts, which are which I certainly have struggled with. I've certainly struggled to sort of come up with clear definitions. But energy makes things happen. Information sort of seems to steer the way things happen. I find it really difficult to go much deeper than that. But I think we need energy and information as part of the cast of characters to tell the big history story, at least to tell it as I do. I mean, I can imagine other tellings of this story, other ways of telling the history of the universe that would highlight maybe different things. But I think this question of how a very simple universe seemed to somehow contain the potential for all the complexity we see around us. That's the magical question. And we know that there was energy in the early universe. And we know that there was something that we can probably call information. So the basic principles that would drive change and that would steer it in some directions and not in others, they were there at the very beginning. But watching how they actually did steer the stuff in the universe towards greater complexities is the magic of the story for me.
Totally. And I think that the beautiful thing of the early universe, and you say it well in your book, of this idea that we essentially need access to free energy, and that for you and I, that looks like chips or food, versus for at the beginning it was gravity, and then we get to this mode with energy was kind of, we had these new energy gradients, and that created stuff like the ability for there to even be a Goldilocks condition, like our Goldilocks place for our planet. And then we get into this weird mode with information where you have the underlying kind of information theoretical concepts of genetic theory and the fact that DNA can, or RNA can replicate, and DNA can kind of produce, copies over time. And then we get to this weird part now where we have all this information within us, in a genetic sense. Is there, I guess, one question I want to ask is, in thinking about our current day, I feel like there's, and in your book you highlight the agricultural revolution, which was this huge, amazing influx of energy to the human race and the human civilization. And then the industrial revolution, which was even 20x bigger than that, all the energy in the ground coming to us. The information age is weird because instead of being based off of energy, like new ways that we as humans are accessing energy, it's all about ways that humans are kind of accessing information, sharing information. Is there anything to learn from the difference between those three revolutions?
Look, I suspect information was crucial at every stage. I mean, one of the very simplistic ways of thinking about information, and I hesitate talking about information because it's such a complex and tangled subject, and I was always looking for simple ways of grasping it. But one simple idea is simply that At the very beginning of the universe, things were not completely random. There seemed to be rules, templates, I don't know what you call them, patterns that steered the way energy and matter worked. Gravity, for example, within the first split second, forces appeared that were not random. They had their own qualities. Gravity had its own qualities. So there were always these very, very simple principles in the universe. And over time, those principles got used to build things that had more complex principles in them. And one of the things about living organisms, I guess, is that living organisms try to actively use information with purpose. It's as if before living organisms, what we call information steered change, but there was no real purpose behind it. It just, information set limits to what could be built and what couldn't be built. Once you have living organisms, you have purposeful agents that are trying to use information to control what happens. So even bacteria have sensor molecules sticking through their membranes that tell them about the chemistry of their environment and so on. So I think each of these thresholds can be described as associated in some sense with increasingly skillful use of information. Agriculture certainly is, because what farmers learned was new ways of managing their environments. I mean, they learned that you can increase the production of food, for example, by diverting water from a nearby river into channels that will give your crops food. They learned that you can, by clearing trees, which we can't eat, you can grow more food. So they're using information. It may not be scientific information, but it's information based on a lot of experience. One of the if you think of collective learning, then one of the interesting things about the modern era is simply the fact that the volume and amount of information that humans work with has increased to a staggering extent. And that's why I think globalization is so important. The fact that since the 16th century, there's been a sort of big bang of information as all human communities everywhere on the earth eventually came into contact. So now humans are sharing information on a global scale. And that's the really new thing in the last 500 years. And I think that was one of the things that sort of synergized information and explains why we've accumulated more information. We've got so good at using new types of information. And, we capture a lot of this by talking about the rise of modern science. So I suspect this is an acceleration in an old process of making use of information, systematic, careful use of information to control what's going on.
Yeah, I love a couple things in there, and thank you for that overview. One, the thing that you said about how pre-life, pre 4 billion years ago, with the rise of RNA and DNA and life as we know it, that bacteria and us. Before that time, information was kind of a different thing. It was something that non-purposefully or non-intentionally steered how the universe could transition through adjacent possibles, versus once we got information, or once we have like kind of the biological version of information, it is an active, purposeful use. All of our sensing organisms and all of the DNA within us, it's kind of a more purposeful, kind of goal-oriented way to think of information. Is that am I hearing that correctly?
Look, I have to say, my own ideas have been evolving over time. And one of the ideas that is really seems increasingly important to me is the division of the universe into agents and non-agents, purposeful entities and non-purposeful entities. It's and once you accept, which I think this is a fundamental idea in modern science, that a non-purposeful universe, a universe that just exists, can eventually generate purposeful beings. then you have a way of talking scientifically about the emergence of ethics and morality. Now, the science is not going to give you the details of those ethical principles, but it can explain why they emerge, because purposeful beings are beings who care about some things. I mean, a bacteria, purposeful beings are designed to survive and reproduce, basically. So there's a sense in which a bacterium, every bit of its machinery, is designed to prefer some futures, the futures in which it survives and reproduces, as against other futures. That's how it's designed. And that ultimately is the foundation of ethics and caring and morality. Now, once you get to mammals, you get purposeful creatures in which ethics is associated with emotions, powerful emotions, a sense of things being right or things being wrong. So I more and more think that the idea of the point at which there emerge purposeful beings is a really critical turning point in big history, a very, very interesting one.
Yeah, and I think, as you said, it kind of changes the law of the adjacent possible there, where, if the goal of the being is to survive and reproduce, then there are certain, futures that are preferred over other ones. And so when you think about possible trees where we could go in the future, it kind of is dictated to some extent both by the laws of our universe and also by our kind of the purpose that we have as beings.
Exactly. And in a sense, this too is very, very simple. This is banal. I mean, when as a schoolboy, I during the days of the Cuban Missile Crisis, I knew very clearly that there were futures I preferred and futures I didn't. I mean, the future in which the whole world was blown up was not a good one. It was definitely not one I preferred. Whereas I think, if you're talking about a rock, the idea of caring doesn't make any sense. The rock doesn't care if humans blow. Actually, the cockroaches probably wouldn't have cared if humans blew each other up, but I cared. Yeah.
Yes, totally. That's funny. I think, and it makes me think. You were chatting earlier also about this Big Bang, this Cambrian explosion of kind of knowledge sharing that has happened after the printing press, and now kind of hyper pushed by things like globalization and the internet. And I think that there's in this connection, this thing in your book that I really loved was how you talked about the different world zones, and how you gave a quote from Marx and a quote from Adam Smith about how crucial it was that these world zones got connected to each other, and that's kind of what turned it. That's like modern capitalism is built, obviously, on the fact that we have a connected and globalized world. It makes me want to ask a question, kind of a selfish question here, or what have you, about the book that I'm writing, which is about this, the rise of this new networked organism. You could call it a Borg. You can call it, in my book, I might try to call it a Terra Sapien. How do you think about, I guess, is that a helpful frame to view us as this new Borg? And if so, what kinds of things can we learn about, like what the Borg wants, or something like that?
Yeah, I said earlier that I think the story raises fabulous questions, and one of the questions, once you start thinking about the near future, is precisely that one. When you look at the evolution of life, you begin with single cells, but even single cells collaborate to some extent with other cells, because they have antennae that tell them what's going on, and sometimes they're responding to other cells. Once you get multicellular organisms, you get billions of cells working together. And they're working together partly because they all share identical DNA, but also because their own survival depends on the survival of the larger organism of which they're a part. Now, I increasingly think we humans, mammals, as a group of species, are probably more interdependent than, say, reptiles. I mean, you can see this in the way they care for their young. This is a species in which you have warm blood, so you need lots of food, a lot more than reptiles, so you need a lot of smarts. But a lot of smarts means a big brain, and it means lots of education. And that means your young are going to be born not quite ready to live. So they need a lot of protection. So mammals in general have to work together. Now, once you get to humans, you get a species of mammal in which not only do they always exist in communities which support each other, um, that they also live in each other's heads because they talk to each other all the time. So what's in my head is not just my stuff; it's human stuff. So it's as if in our brains we're already beginning to live inside some sort of superorganism, and since the coming together of all different human communities within one global community in the last few hundred years, this kind of mega organism, I think, has become more and more significant. What we see is individual humans. So we see it's as if we see the individual cells. It's very hard to see the larger organism. But we're beginning to have to see it once we realize that this larger organism has to deal with problems like global warming. We are now so utterly interdependent globally, um, that we have remarkable phenomena like 192 nations signing up to a document about climate change at the Paris Accords. That is absolutely remarkable. So I think certainly the tendency of many parts of big history is towards the creation of sort of groups that are so interdependent that eventually you have to start thinking of them almost as a single organism.
Yeah, I love that. And this is a history. There's a great in your book you reference the Self-Organizing Universe, which is a beautiful book. And then there's another book called The Origins of Life by John Maynard Smith. Have you read that, by the way?
Yes, I know it. Yep.
Okay, beautiful. Yeah, it's a great book, and it is, as you say, it's that exact thing. And just to reflect it for our listeners, this idea that a multicellular organism, that they all have the same DNA, but they all kind of play different roles. Like my, heart is different than my eyes or whatever.
Yep.
And but they all want the whole. They want me. They need me, this bigger thing, to survive in order for them individually to survive. And
Yeah,
it's
because I mean, you
Mhm.
compare a bacterial cell with the cell in a microbe like you or me, and the bacterial cell does everything. It's a bit like a sort of peasant, it does everything. But the cells in our bodies are specialized. They're so specialized that they cannot survive without the other cells, and that's the basis for their profound interdependence, and for something that metaphorically at least we can probably think of as a sort of altruism. I mean, it's a self-interested altruism, like all altruism, I suspect.
Yeah, I think in that interdependence, and there's obviously those debates in with biologists of can altruism versus group selection and all of these things. But there's this, as you say, there's this, there's like the superorganism kind of colony ant species where you have the queen, which does all the reproduction. So again, there's a division of labor here, just like with the cells, and you have the worker people who are doing like getting food. And similarly, now with humanity, we see this new superorganism, this new multicellular thing that from us on the inside, it's kind of hard. We see ourselves as the important ones, but actually we're part of this new thing. And so, yeah, trying to see from that perspective could be powerful. Do you think you were kind of hinting at something that I wanted to ask you about, which is, this idea that we have a theory of mind with each other, and that we're already kind of in each other's brains already, and there's this whole kind of there's this beautiful concept of the ethnosphere, which is this like set of ideas and myths and information and knowledge that kind of exists in all of our brains collectively. How do you think about the ethnosphere and how that might evolve with like us as humanity?
Actually, the word I'm more familiar with is noosphere,
Mm,
which goes back to Vernadsky, the idea that there's this sphere of ideas. Um, are we talking about the same thing?
we are. Yes, true. Yep.
Yeah. So I love the idea of the noosphere. I mean, it's metaphorical, and you have to sort of keep in mind the difference between the metaphor and a kind of literal description. But it's very powerful. One of the discussions I used to have with my students when talking about collective learning, because the way our minds work, they drive us all the time to think of ourselves as a single individual. But you can ask yourself the question, if in my lifetime I had never talked to another human being, never communicated with another human being, how much of the stuff that is inside my head now would actually be there? Now, you asked that question, and I don't think it takes long to figure out the answer, which is almost none of it. In other words, most of the stuff in my mind and your mind was not created by me. It was put there by other people through conversation, in school, through reading, through the internet. So, though we look at the world and we see lots of individual humans, there is a sense in which this kind of noosphere already exists, and we are not separate humans, but kind of nodes within the noosphere.
100%. And yeah, I think I really love that question. It's like all the things in my mind are, yeah, obviously from everybody around me. And it's also very different. This is the classic, one of the big signs of cultural evolution is back in like if I was put into the Amazonian rainforest, I would die immediately,
Yeah,
because I haven't had the cultural learning to take it from the folks around me. I think that one thing I might push back on, or that I'm maybe exploring more, is when to treat something like the noosphere, the noosphere, as metaphorical, and when to try to treat it as a kind of rigorous biological myth organism in
yeah.
and of itself. I don't know how to think about that, but yeah.
No, nor do I. I mean, the question's really important, but I'm going to duck giving an answer to that, and I suspect the reason is because it's one of those questions to which there's not a yes no answer. You actually have to talk about a kind of ambiguous borderland, and the same thing is true of biologists. If you're talking about a multicellular organism, at what point do you say we're talking about one organism? If you have some sponges, you can take the sponge and you can push it through a sieve that separates all the cells from each other. And then when it gets to the other side of the sieve, it will reassemble. Now, is that a lot of cells that simply are collaborating, like humans in today's world, or should we regard it as a macroorganism? And I suspect the answer is that both perspectives are helpful, which is
Yeah.
a sneaky way of avoiding your question.
No, I love that though. That and I think it's a great coherently plural or perspective where it's yeah, having both perspectives is good, and they are both helpful in their own way. I think I would love to spend the last kind of little bit here discussing. Well, the big history project that you've co-founded is amazing. It's as you said, for us or for you and I, we were not taught the kind of big history perspective as kids. And so, the big history project, you're kind of helping folks and helping high schoolers and high school students and high school teachers understand big history. Could you tell me, I guess, a little bit about, how you see big history? How has it gone? Are people into it? What's kind of the vibe with folks in it?
Yeah. Well. Look. First, I believe very strongly that something like big history ought to be taught in every school, in every country in the world today, because the truth is that in my lifetime, we humans have become a planet-changing species. The challenge before us is how to manage an entire biosphere. We're not doing it very well so far. But for our own sakes, we have to learn how to do it. That is something utterly new in planetary history. And if if educators are to help young people understand the nature of the challenge they face in the next few decades, we have to give them a perspective that helps them understand the evolution of the whole planet and of life on Earth. And that's the big history perspective. So that's why I really do think that the Big History Project is very, very important indeed. It was, you may know the story, but I did a teaching company course on big history, and Bill Gates came across it in, I think, about 2007 or 2008, and he loved it, and he reacted the way, you know, I always have to big history. He thought, "Damn, I wish I'd been taught this in school." And
Mm-hmm.
I started teaching big history because I wished I'd been taught something like this in school. So he, I was in San Diego at the time. I was teaching at San Diego State University, and I met him in San Diego, and he said, "Look, if you're interested, this is what I'd like to suggest. I'd like to suggest the building of a free online course in big history that would be available for free to high schools really everywhere in the world." And of course, I was very excited by the prospect. I had just got a job back in Australia, so I was about to return to Australia. So it became a sort of US Australia project. And over the next 2 or 3 years, we put it together. Now, for the last few years, I've had very little to do with it. So I can say without bragging that I think that what has been built is very impressive indeed. As far as I know, it's being taught in perhaps 2,000 schools in the US, several hundred in Australia. That's the good news. There are lots of schools that are teaching it. The bad news is that I was really hoping big history would take off much faster than that. And if you'd asked me 10 years ago where I'd like to see big history, I would have liked to have seen that there were Chinese versions of it, there were Japanese versions, there were Russian versions, there were Brazilian versions, and that big history had been incorporated formally into syllabi because educators saw its importance. Now, that's not happened. And I think it's a shame. And I spent a lot of time trying to figure out why it's not happened. I think part of the reason is that the whole world of modern knowledge is so locked into the idea of specialist disciplines that it finds it really difficult to take seriously the idea of a way of thinking that crosses multiple disciplines. Um, and there are many subtle barriers to teaching and thinking in this way. As an academic, if you spread yourself across so many disciplines, you can very quickly lose street credibility because they say, "So, what's your expertise as an academic?" Well, I would say my expertise is in spreading myself across lots of disciplines, but that's not an answer that really works in the present day world. So that's my general answer to your question. I'm very excited by the fact that big history is now a recognized way of thinking about the past. Lots of people are enthusiastic about it. It's being taught in several thousand schools, mainly in the English speaking world, but there are some in Japan, in Korea, in the Netherlands. There are some universities that are teaching it, not that many. The bad news is I wish, I had hopes that it would spread much, much faster.
Yeah.
And I'm not sure what is necessary for big history to spread faster. I would love to see it become a formal part of school curricula. It wouldn't need to bounce out existing syllabi at all. You'd simply need one or two big history courses in high school syllabi so that students know this story. And once they know this story, and we know this from practice, it will synergize all the other learning they do. They'll understand how geology fits in with chemistry and with human history and with cosmology and with physics and so on. And so they'll see the links between everything.
Yeah, I think, well, there's always just that fun moment where you're just like a normal historian, and then all of a sudden Bill Gates is like, "Hey, man, like let's chat," and you're like, "Okay." Um, And I think that there's, well, I think we should chat more about ways that I can help in that with big history and how to help it grow. Because as you say, I think you give a great desire or a great raison d'etre or whatever for big history, which is we have to think about the whole biosphere, and so something like big history is necessary for that. And I think that and just also, as you said, the synergistic aspects of it are so beautiful. For me, learning biology and chemistry as a high schooler, I didn't like them at all because there was no tree of information or web of knowledge for me to stick them onto. But now, after reading your book and other books in big history, they feel connected, and I know where they can kind of fit in my mental map. And so I am excited still, I guess, for the long term vision of big history, and also big history books like yours or like Sapiens or Guns, Germs, and Steel that kind of help us take this bigger perspective.
Yeah, look, I shouldn't be too pessimistic because I see all sorts of signs that there are many areas of knowledge in the modern world where people understand the importance of interdisciplinarity. I mean, all the work that goes into understanding climate change is profoundly interdisciplinary. So one possibility is that the big ideas of big history are already appearing in other domains, and we don't necessarily need the label big history. That slowly it'll become more and more obvious that deep understanding of what's going on in the world requires a willingness to look across many disciplines. But the other thing you say, Reese, that triggered something with me is the idea of people who couldn't make sense of the details. Now, I think there are a lot of people who have that sort of mind, and I think I was one. I think of it as framework thinking. When I was at school, someone gave me the details. I couldn't make sense of them. I needed someone to give me a big framework before I could make sense of things. Um, and I think there are a lot of students like this. When we first began teaching big history in Australia, one of our pioneering schools, I heard a wonderful story. A history teacher who had agreed to teach big history, very brave of him. He was actually a specialist in Elvis Presley, and he used to teach history through rock and roll. Fabulous teacher. Um, he told me a story about a class, the first time they taught big history, in which someone asked a question about the Big Bang. He hadn't a clue about the answer. So as a teacher, you think, oh my God, what do I do? And he was thinking, should he ask the science teacher? Should he set them homework? And then he suddenly remembered in the class, there was a kid who was known to be a science nerd. And that kid didn't have terribly high status, wasn't really performing terribly well. But he turned to him and said, can you help me out here? And the kid nailed it, absolutely nailed it. And he said over the next few months, he watched this kid. His body language changed. He started standing taller. Other members of the class began to respect him because he became the go-to guy whenever the teacher had a problem with the science. And so I think that kid was the sort of kid who is actually failed by modern education. Modern education does not work for kids like that. And I think to some extent it didn't work for me and probably for you. What we need is, particularly for people who have minds like that, to present them with a big framework. The framework doesn't have to be perfect, but the framework will provide a context for their thinking. And I think that kid was a wonderful example of how big history can enable the thinking of many students.
100%. Yeah, I love. Yeah, framework thinking is definitely. I would identify myself as a self-identified framework thinker. I want to kind of wrap up here with a little fun game at the end where I ask you if you think something is underrated or overrated, and you can just give your quick 30-second I think it's
Okay.
underrated because blah blah blah. And so these are going to be difficult, but try your best. What do you think? Do you think the agricultural revolution was underrated or overrated?
it seems more and more important to me. So I think it counts as one of the two or three big turning points in human history.
Beautiful. Underrated. What do you think about the Industrial Revolution?
Ditto. Although my ideas on the Industrial Revolution are changing, and I more and more prefer the term fossil fuels revolution, because I think the critical thing was actually the sudden discovery of a huge amount of cheap energy. I think that synergized everything. Suddenly, entrepreneurs throughout the world, suddenly they have access to cheap energy that can get things done, and they're figuring out, how can we use this? How can we exploit it? So I prefer the term fossil fuels revolution, but I think it was as fundamental as the Industrial Revolution.
Yeah,
Sorry,
I
as the Agricultural Revolution.
totally. And I think I agree as fundamental, though I think that the Industrial Revolution or the fossil fuels revolution is rated more highly by society just because it was more recent. But I think it's a little bit overrated, perhaps. But I see your perspective. What do you think about the equation E equals MC squared? Underrated or overrated?
Well, look, in teaching big history, because I'm a kind of mathematical idiot. I'm not. I wish I wasn't. I wish I was good at maths. Um, I took a decision, and it's a personal decision, to not try to teach relativity or quantum physics. I sort of wave my arms at them occasionally. So I suspect in the way I teach big history, E equals mc squared is underrated. But the fundamental idea that energy and mass are really the same thing in different forms is both magical and one of the core ideas of big history, I think.
Totally, yeah, a pretty crazy one. Well, beautiful. Well, thank you for playing that game. Obviously, there's no right answer there. And again, David, thank you for your explanation and your thoughts around big history overall. I think that there's a lot of juicy, obvious topics within there, and also thank you for co-founding and kickstarting the Big History Project to share it with folks. Is there something for our listeners, by the way, that they should checking out, your book Origin Story? I super recommend maybe checking out the Big History Project. Is there anything else to kind of check out that you'd have our listeners kind of do after they listen?
Yeah, the Big History Project, you can find it very easily just by Googling it. But it's also worth looking up the IBHA, the International Big History Association, which has its own website, and that has bibliographies. The IBHA has conferences every 2 years. The next one will be in India. So it's worth checking out the IBHA, which has lots of resources. Yeah, that's probably the main recommendation.
Beautiful. Yeah, no, that's great. And I'll definitely add those in the show notes. And thank you again for coming on today, David. And goodbye, everybody.
Hope you enjoyed that episode. I want to cover a couple key points here, and I'll try to keep it short, but this is the book that I'm writing, and so obviously I have more thoughts about this than normal. I think it's quite interesting how the Cold War made him think of the other side and interconnectedness. And for us, the internet and COVID are going to be the things that help us think of interconnectedness. David makes the point, David makes the point that in order to understand today, we need to understand our history, and not just the history of, sapiens, but also the history of life on Earth and of the universe. And I mostly agree with that perspective. Though it's interesting, I'm not sure if it's necessary. I think it is pretty crucial because it can give us, it can, no matter what, it's from a neglectedness perspective, there's a lot less people thinking about the history of the next 100 years in the context of the history of the universe. And so I do think it is helpful to take the macro perspective, purely because it's not often taken. But more than that, I do think that we can determine some underlying forms that then we can use to understand today's life. And whether this is, thinking of energy and information and how those have changed through time and how those are going to change in the upcoming, the near future, or whether it is something like, the new sphere or the ethnosphere and how that is part of our theory of mind, or whether it's something like just autocatalytic replicators, and that those are roughly what we have on the internet now with memes. I think there is some juiciness to be explored from this macro understanding, that in order to understand our present, we need to understand the past, the deep past. I do also just super agree with what David said about the Big History Project and how if we want kids of the future, like, all of them should understand our place in the cosmic evolution. That's a pretty crucial thing for stewarding the biosphere and the incoming AI. The third point here is I just want to make a recomment about the transitions and what David talks about as these macro transitions. He, I think, gives 8 of them. There's a book by John Maynard Smith that I referenced in the show that gives about 8 of them. I think it's roughly correct to bucket them in terms of, I love this idea that, energy exists, or what do I want to say here? That there's kind of an inevitable trajectory of how things evolve based on the entities available at a given time. And so, when we just had hydrogen and gravity as the free energy, we kind of knew that it was all going to bunch together, turn into stars, and that those stars were then going to make these new elements. And kind of once we get to that new place, new elements, that's like the first big transition, or the first, we're in the second stage now. We've moved from physics to chemistry, we have new elements, and you can kind of combine chemistry and biology here, in my opinion, because those new elements combine through electromagnetic forces to form molecules, and those molecules get in cycles, autocatalytic cycles, where they produce more of the same thing, and that then will eventually produce underlying information copying mechanisms like we have in RNA that then provide for the evolution of life, and that evolution of life will eventually try to capture free energy like cyanobacteria did with photosynthesis and like animals did with respiration. That's all kind of stage 2, is the shift, taking the starting point of elements, turning them into molecules, turning them into replicators, turning them into DNA, and then using that, kickstarting the evolution of all life through that underlying information evolutionary system based off of DNA. Then we get to stage 3, which is humans. And humans are different, as David notes, because we have a new kind of evolutionary mechanism, which is cultural evolution, the ability to represent abstract concepts of the land and of tools and of social relationships all in terms of language, and that we can pass that through time. That then you can again see an inevitability there, where that once that kind of language starts to occur, it is going to naturally lead to people being better at finding where's the free energy. Sweet, let's develop farming techniques, and boom, you get the agricultural revolution. We start exploiting free energy and domesticating animals. And then that group again will eventually say, okay, where's the next source of free energy? Fossil fuels. And then you get the Industrial Revolution. And so, yeah, so I like to think of it in these big 3 stages, I think, is my kind of preferred way to view big history. Cool. The 4th point here is on multi-scale dynamics and how David, and when I asked David, hey man, is like the point of view, is viewing the world as a Borg, is that helpful? And also is it metaphorical or non-metaphorical? And something like the ethnosphere as well, or the new sphere is like, is this metaphorical or non-metaphorical? And he said that it's both. Just like with multicellular organisms, thinking of them sometimes as the perspective of individual organisms, and sometimes thinking of them as one general unit. Both are good. So it's just a classic coherently plural perspective where the different metaphors provide you with different answers around what you want to view. And finally, the 5th point here is that, I think this framework thinking is one that I super agree with, and it really has been amazing for me to see my re-energized interest in biology and chemistry and physics, which I wasn't truly excited. I wasn't really excited about them in school, seeing that reignited by big history, because I now know where to kind of place things on a mental map. That's pretty helpful. So, yeah, I think it's a good convo. I think that David is obviously thinking about some pretty wide-ranging topics, and it's cool to see him still be contemplating them with, the stuff he's thinking about, like purposeful agents and stuff. So thank you again for listening, and hope you enjoyed today's episode. And I'm especially curious if you have feedback on today's, because it's related to my book. Okay, thanks everyone.